All right, so now let's look at the third, and for most of you, final way that we're going to learn how to solve quadratics. As I had mentioned, I think in the very first video when we started looking at solving quadratics, for those of you who get ahead of pace, there will be an additional video on completing the square, which will be a fourth method. However, it will be a bonus objective, and it will show up as a bonus question on the unit test, so you do not have to know it. But the fourth way is going to be the quadratic formula. Quadratic formula is great because it can be used with any equation. Unlike square roots that have to be used with equations with no linear term, and unlike factoring, which can only be used with equations that can be factored, the quadratic formula can always be used. It is a little bit more of a tedious process, however, which is why if we can use the square roots, we want to use the square roots, and if we can use factoring, we want to use factoring. When we use quadratic formula, we first change to standard form, so that ax squared plus bx plus c, and either set it equal to 0 or get it equal to 0 if there is no y. This is going to be the formula. You must memorize this formula. Not only will it be important for my class, it will also be important for future math courses as well as your ACT once you get to that point. And it is going to be a negative b plus or minus, because remember we want to get two answers, the square root of b squared minus 4ac all over 2a. We will use order of operations and reduce that as much as possible. There is a song to help you remember the formula. There is a video link on gilpinschool.net to reach that quadratic formula song. I'm not going to sing it. So let's go ahead and look at some examples of when to use that quadratic formula. There are 3 examples. So again, remembering what standard form is. So I tried to put some additional words that gets used. We also get roots is used for the solution, as well as zeros. So we have a solution, we can find the root, we can find the zeros, or we can find the x-intercepts, however we want to phrase that. So first thing I'll do if I'm finding x-intercepts or finding roots is I'm going to plug 0 in for y, and I get 0 equals 2x squared plus x minus 3. So my formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I am going to use the quadratic formula because although this may be factorable, I know that if my coefficient is something other than 1, it's a very long process because I have to use the factor sum tables along with the factoring by grouping. So I would prefer not to have to try and factor this. So that's why I'm going to go ahead and choose the quadratic formula. Remember the b, your b is always going to come, well, let's start with a, I guess. A is always going to come from my quadratic term, so my a is 2. My b is always going to be the coefficient of my linear term. If nothing's written there, it's 1, because 1x is the same thing as x. And my c is going to be my constant. Don't forget the sign belongs to the number, giving me negative 3. Plugging all of that in, I get x equals negative b, so negative 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2a. So my order of operations, and I should plug my a in, all over 2 times 2. My order of operations tell me to do groupings first, so the top is grouped together and the bottom's grouped together. On top, I also notice that all of this is grouped underneath the radical, so that's where I will start, giving me negative 1 plus or minus the square root of 1 squared is 1 minus 4 times 2 is 8. I'm going to leave that as negative 3 because I want to talk about that, all over 4. So now I'm going to multiply these. If sign belongs to the number, I'm going to think of this as a negative 8 times a negative 3, and that's going to give me a plus 24 there. I see mistakes non-stop on people saying, oh, 8 times negative 3, all that's going to become minus 24. It doesn't. All of this becomes a plus 24. So I have now the negative 1 plus or minus the square root of 1 plus 24 all over 4, which gives me negative 1 plus or minus the square root of 25 all over 4. So in the previous page, I showed you that we always want to reduce as much as possible. That means if you can do something in math, do it. I know that this is 5, so I'm going to go ahead and do that. I'm going to say that this is equal to negative 1 plus or minus 5 all over 4. Now, Order of operations say to do the top and then do the bottom. So on top, I'm going to start by doing -1 plus 5 because, again, if I can do something in math, I want to do it, and I can do that. So -1 plus 5, I'm going to say that's going to be a positive 4 over 4, which equals 1. There's one of my solutions. I'm also going to do -1 minus 5. -1 minus 5 is going to be -6 over 4, which is going to be -3 over 2. There are going to be my two solutions. So I have an x-intercept of 1 and an x-intercept of -3 over 2. A lot of work, a lot to internalize, and a lot to process. Like I said, it's not necessarily hard stuff. I mean, it's a lot of order of operations and things like that that we've learned, but it's very tedious, and there's a lot of steps and a lot of places to make errors, which is, again, why if you can use square roots or if you can use factoring, we want to do that. Let's look at example 2. So example 2 looks like, well, let's change it to standard form first. So changing it to standard form, I'm going to subtract 4x, and I'm going to get x squared minus 4x plus 7 equals 0. This looks like it's factorable, but if I try to find two numbers that multiply to be 7 and add to be -4, I cannot find any. So I'm going to have to go ahead and use my quadratic formula. A is going to be 1, B is going to be -4, and C is going to be 7. So I have x equals -b plus or minus square root of b squared minus 4ac all over 2a. B is -4, so -b is going to be a -4 or 4 plus or minus. We always plug in parentheses. Remember that from Unit 1. Minus 4 times a times c all over 2 times a. Again, from here, I'm going to go ahead and use order of operations. I know if my negative is inside of the parentheses, when I square it, it becomes positive. So I know this is going to become 16. 4 times 1 times 7 is going to be 28. So I have 16 minus 28 all over 2. 16 minus 28 is going to be -12. As I said before, if we can simplify, we always want to do that. So I know that if I have a negative under a radical, I can take an I out. I also know I should always check for perfect squares with radicals. So I know that that has a perfect square of 4 underneath it. So I'm going to go ahead and rewrite this as 4 plus or minus I times the square root of 4 times the square root of 3. I know that the square root of 4 is 2, so it becomes 4 plus or minus 2i square root of 3 over 2. And then the last thing I do, I check for a GCF. I can factor a GCF of 2 out of the top. After I factor it out, I can cancel it with this 2. So factoring out a GCF of 2 is going to leave me with 2 plus or minus I times the square root of 3. I then cancel my 2's. I'm going to kind of skip that in between step because I'm out of room, and I'm going to be left with 2 plus or minus I square root of 3. And that 2 that I factored out canceled with the 2 on the bottom, leaving me with that as my final answer. So what does it mean to get an answer that is a complex number with an imaginary part? That we will talk about in another objective. So before I finish this video, I want to go back to one of the examples we looked at in the previous video with factoring. We looked at how we could use factoring to get to this point and then set each piece equal to 0. And in that previous video, when we solved this, we saw that x was 2, and this is the point that I said, we don't know what to do with that yet. We're going to hang on to it because we cannot factor it. Well, now we know what we can do with it. We can use the quadratic formula with it and say that for this piece, x equals -b plus or minus the square root of b squared, which 2 squared becomes 4, minus 4 times a times c all over 2 times a, where my a is 1, giving me -2 plus or minus the square root of 4 minus 16 all over 2, which is going to give me -2 plus or minus the square root of, again, -12 all over 2. Since we just looked at how to simplify the square root of -12, I'm going to do it fairly quickly, and I'm going to skip some steps in my work, which is not good. -2 plus or minus I, well, I'm going to go ahead and say that that's 2i square root of 3. Since 12 has a, I can take the I out since it's negative and it has a perfect square of 4, all over 2. Again, I factor out, and I will show that I skipped last time. I factor out the 2, giving me negative 2 plus or minus I times the square root of 3, all over 2. My 2's cancel, so I have my one solution of x equals 2. I have my second solution and my third solution of x equals negative, oh, and I'm sorry, I have a mistake here. I'm rushing. This should have been a 1, because when I factor a 2 out of negative 2, I'm left with negative 1. Negative 1 plus or minus I times the square root of 3. So to summarize, quadratic formula can be used anytime, but as you can see, it's a long process, so do make sure and check to see if you can factor or use square roots first.